Hi guys, today we're going to have a recap on energy and efficiency. So there are two equations for efficiency. So let's start off with the first one. Efficiency is the useful energy output divided by the total energy input. So that kind of makes sense. You have the useful energy divided by the total amount of energy, and that should give us how good something works. So how efficient something is. Now the unit for efficiency is dimensionless, and what that means is it doesn't have a unit. And how we know that is because from the equation, joule divided by joule is just 1. So the unit for efficiency is nothing. Another equation for efficiency is the useful power output in watts divided by the total power input in watts. Again, unit is dimensionless, watts divided by watts. Efficiency has no unit. Now, how we get here from here is what I'm going to discuss here. So we know that power is the energy transferred divided by the time taken, joules per second. Simplify that to P is equal to E over T. Now, if I put this equation into my first equation, remember energy is equal to power times time. If I rearrange this, multiply both sides by time. If I multiply this side by time, I'm left with E, and if I multiply this side by time, I've got power times time. So if I sub this into my first equation, like I said, I have useful energy, which is power times time output, divided by total energy input, so total power times time input. I have useful power times time output divided by total power times time input. Now the time taken is the same, so the t's cancel. So you're left with useful power output divided by total power input, which is the second equation for efficiency. So this is just rearranging equations, subbing them back in and trying to work it all out together. So I want you guys to look at this example. You have a wind blower. It's blowing winds away. So what type of energy does the battery store? Okay, so the battery fuels energy. The battery stores chemical energy. So that's a chemical store. The battery fuel is energy. The battery fuels energy for the electric motor to work. What type of energy is transfers to the leaves? So you have your battery, which fuels energy to make the electric motor to work. So you go from chemical to electric and then to something which makes the leaves all move around. Now remember, it's movement energy. So that's right, it is kinetic energy. So you have leaves moving around due to kinetic energy. A leaf blower is not 100% efficient because energy is wasted. And energy is wasted to a thermal store. So energy is wasted by heat. And that is a typical exam style question. It will ask you what is stored, why it's not efficient, and then you may build up the question to use these equations. So I want to leave it on this, actually I want to do this as well, but here's a fun fact. Laptops are 85% more efficient than desktop computers, so that's using the fact, like a real world example. Real big desktop computers waste energy a lot via heat and sound. You can hear them and their motors, where laptops are pretty good for just being more efficient in general. I want to pause the video now and see if you guys can work out the total, what the efficiency is, and give the units when we have the total power input and the useful power output. So yeah, pause the video and try and work it out. Okay, hopefully you've unpaused the video now. So if you have the total power output, we're going to use this equation here. Sorry, the total power input, and we have the useful power output. We're going to do 360 divided by 750. and multiply that by 100, you have 48%. So the efficiency of whatever device we're dealing with is 48%. So it's not that efficient. But what I've done here by multiplying by 100 gives me what it is as a percentage. Okay, so hopefully you guys got that right. If not, no worries. Well done to whoever got it. So yeah, hopefully that helps. Thanks for watching the video. Bye guys.